All right, in this video, we're going to look at finding the terms of an arithmetic sequence. So when the difference between consecutive terms of a sequence is always the same, such as 8 to 11 to 14 to 17, then that sequence is called an arithmetic sequence. So for this sequence, if we look at the difference here, 11 minus 8 is 3, 14 minus 11 is 3, 17 minus 14 is 3. So we just keep adding 3 to get from one term to the next. Then that sequence is called an arithmetic sequence. So the difference between consecutive terms, like 11 minus 8, 14 minus 11, is called the common difference. And to find the common difference of an arithmetic sequence, all you have to do is subtract any two consecutive terms. So find the ones that look like they're the easiest to subtract and make that happen. So arithmetic sequences are, in essence, the linear functions of sequences. The only big difference is that with linear functions, we can put in negative values for x and decimals and fractions. With sequences, we stick with non-negative integers. So the following shows the first four terms of our sequence. And the first term, if we plug in, that first term is 8, second term 11, third term 14, etc. Notice that it makes a line, hence why it models linear functions. So if we want to come up with a rule for our arithmetic sequences, first up, the common difference between the terms, 3 in this case, is going to be the slope of the line. So the scale here is the y-axis is by 2s and the x-axis is by a half. But if we just look at it, our slope is the same as our common difference. So between the first and second term, we have a difference of 3. So 11 minus 8 over 2 minus 1 gives us our slope of 3. The y-intercept is what we get when we have the 0th term of our sequence. So if we're adding 3 to get to each of these new terms, then we just have to subtract 3 to get to our y-intercept, which in this case is going to be 5. So if our first term is 8 and we add 3 to get to 11, that means we subtract 3 to go the other way. So our sequence rule is going to be pretty much like the linear function y equals 3x plus 5. It's just we're going to have a sub n equals 3n plus 5 for values of n that are 1 or higher. And we can check that by plugging a 1 in for n. 3 times 1 plus 5 gives us 8. Then when n equals 2, 3 times 2 plus 5 gives us 11. So we do generate the terms of those sequences. All right, example 5, we're going to find an explicit formula for the nth term of the following sequences, which is nice because then you could ask, well, what's the 1000th term of the sequence without actually having to list out them all of those terms. So our common difference in this case is 7. We can just do negative 24 minus negative 31 is 7. So that's the slope of our line. So we are adding 7 to get from one term to the next, which means to get the y-intercept, we want to subtract 7 from negative 31, which gives us negative 38 as our y-intercept. So our rule is 7 times n minus 38. So if we plug in a 1 for n for our first term, 7 times 1 is 7 minus 38 is negative 31. So if I asked you for the 1000th term, you could just plug 1000 in for n and you'd get something in the 6,962 as the 1000th term. Part B, 37, 67, 97, etc. First up, our common difference, our slope is going to be 30. We're going up in value by 30 each time. So if we're adding 30 to go to the right, then to get the y-intercept, we want to subtract 30. So our y-intercept is 7. So our rule is 30n plus 7. So if I asked you for the millionth term of this sequence, you could just plug in a million and get the right answer. All right, that about does it for this video. Thanks for watching. I'll see you next time.